One thing about parabolas is everything else, ellipses and hyperbolas, we had two. They either were vertical or horizontal. With parabolas, there are vertical and horizontal, but then there's also point up, down, left, or right. So with the vertical parabola, y minus k, this is kind of your normal parabola. Y equals x squared. The y doesn't have a squared, and the x does. So that's kind of what you've been doing ever since Algebra 1, y equals x squared. The plus or minus isn't always there. What that is for is if it is plus a, that means the parabola goes up. If it is a minus a, the parabola points down. Okay, and again, that's the typical parabola that you've always had that we deal with the most. The horizontal parabolas, that you probably didn't come across until last year. So if you have a positive a, it's going to open to the right. If you have a negative a, it's going to open to the left. And that's what this explains down here. If a is greater than 0, the parabola is either up or right, because that's what positive is. Positive is up, positive is right. If a is less than 0, meaning it's negative, then it's going to open down or to the left. And that's the kind of more untypical one where it's x equals y squared. So going back to this equation right here, whenever you're given a big long equation that's not in any kind of standard form, same thing, you look at the a x squared and the y squared. If there is only an x squared or only a y squared, then right away you know it's a parabola. Now that's when you combine everything. Okay, you have to get all the, if there's more than one x squared or y squared, you have to combine like terms, because you don't know when you combine them, maybe now the values in the front turn out to be the same, or one of them cancels. So again, circles, a and c were both positive, and they were the same number. For an ellipse, a and c were positive, but different numbers. Hyperbola, a and c were just different signs. They could be the same number, different numbers, it doesn't matter. And then for parabolas, you either have an x squared or a y squared. Okay, and that's when it's not in standard form, and we just ask you to identify the conic. Obviously today everything's parabolas, so we don't have to identify that, but on your quiz it's going to all be mixed up, and you're going to have to be able to know which one to graph or write the equation of depending on the information given. The other stuff that's important is this formula right here, a equals 1 over 4p. And the lattice rectum length, or also called the focal diameter, a lot of the application problems we do, again, depending on what book you use, depends on what word it used, but focal diameter and lattice rectum length are the same. The focal diameter kind of makes a little bit more sense because it's the diameter of the parabola that goes through the focus. So from parabola to parabola, the endpoints of the focal diameter or the lattice rectum will tell us how wide or skinny the parabola is. So that's part of what you're going to need to be able to graph when you graph these parabolas. The other important part is p. Okay, p is the distance from the vertex. So a parabola still has a vertex, okay, which is a little different than the vertices of a hyperbola or an ellipse. The vertex is either the top or the bottom, the far left or the far right, depending on whether it's vertical or horizontal. And it's that distance that you will be able to plot the focus, you'll be able to plot the directrix, which is a line, and be able to have all the parts of the parabola done correctly. So if you look at the picture of it, this p right here, okay, that's the distance p from the vertex to the directrix, which is a line, vertex to the focus. Focus is still a point. There's just one of them in a parabola, but vertex, focus, those words are all familiar with ellipse, hyperbola, and parabola. So you've got to be able to know how the characteristics of each when you're given. So if you're given some kind of statement and a directrix is mentioned, or a focal diameter or a lattice rectum, those are the only things associated with a parabola. If you're just given a vertex and a focus, you don't know whether it is an ellipse and a hyperbola or a parabola. So you just have to have a little bit more information to do that. Notice the parts that I expect you to graph is the vertex, the focus, the directrix, which the directrix is this dashed line. Kind of think of it like the asymptotes of a hyperbola. And then the endpoints of the latus rectum or the focal diameter, okay? And that distance right there is right here. It's 4p. So we have to be able to find p. So if we're given an equation, we know what a is. We can plug in a and solve for p. If we're given some information and we know p, we can find a to write the equation. But those endpoints right there, this distance right here from endpoint to endpoint is going to be a distance of 4p. And you have to plot those points because that's going to determine the width of your parabola. That is something that you have to have. Ellie?
But is the latus rectum the whole, like,
Mm-hmm. Yep.
the whole thing, not
From point to point. So this whole thing is the latus rectum from endpoint to endpoint. And that's why sometimes focal diameter is a little bit more descript word to use, because it's the diameter that goes through the focus. It's that whole length right there, okay? The whole entire length. The endpoints of the latus rectum are what's going to tell you how wide or skinny the graph is. The axis of symmetry is something that you might need to write down, and an axis of symmetry, we're only going to have that when we're dealing with parabolas. If you want to graph that, if that's something that you do, then that's fine. It's not necessary. Okay, if you want to draw the axis of symmetry, I don't draw the axis of symmetry, but if you want to draw that in, if that's helpful, you can. Just make sure it's a dashed line. And then I put the line in for the latus rectum. We don't draw that line. That's not something you actually draw. I just had to draw it in there so you could see what it actually represented. Okay, and when we do the examples, I'll show you what I expect to see as far as a graph goes. Okay, if you need me to go back to this at the end, I will do so. All right, so this first one is not really in standard form yet. Okay, standard form. First, let's look at it. We see a y and we see an x that's squared. So that tells us which one it's going to be, horizontal or vertical. The y is by itself and the x is what's squared. So standard form for that is y minus k equals a times x minus h squared. That is considered standard form. That's the form I want it in when we look for the standard equation. So what that means is I have to rearrange some stuff. I don't have to complete the square. That's already done for me, but I do have to rearrange it to get it in standard form. So I need to bring this 6 over. Now it's a little bit closer. The only thing that's left now is this y value has to have a coefficient of 1. So in order to do that, I need to get rid of that 2. The only way to get rid of that 2 is divide by 2. As long as I divide everything by 2, then I can do that. And then I have standard equation. Y minus 3 equals, and then this is where I pull my a out, 3 over 2 times x minus 1 squared. So there is standard equation. So we didn't have to complete the square, we just had to rearrange a little bit. All right, from this point, really the only thing I like to write down before I graph it is the vertex. If you can write more stuff down, then that's fine. But I like to plot it, figure out kind of where everything's going to be, and then go fill in the blanks. So the vertex is still hk. So h is 1, k is 3. So that's kind of from way back, finding the vertex. The vertex is kind of similar to the center of a circle, ellipse, and hyperbola when dealing with a parabola. So y equals x squared. That's our typical. A is positive, so that means it's going to be up. That means our focus is going to be in the middle, and our directrix is going to be outside. So if you need to make yourself a little sketch like that, just so that you kind of have an idea of where everything's going to be, then do that. It's not necessary, but that's what the graph's going to look like. So I start with the vertex, 1, 3, and I plot that point. And then I have to figure out, I can't just put the focus and the vertex, directrix wherever I want. I have to find that distance. The distance from the vertex to the focus, the vertex to the directrix, is the distance of p. So this is where I use a equals 1 over 4p. A is right there, or right there. So 3 over 2 equals 1 over 4p. Now I just cross multiply. 12p equals 2. Divide by 12. P is equal to 1 over 6. So p is the distance from the vertex to the focus, vertex to the directrix. So I'm going to go up 1/6, and there's my focus. Now, I don't care if you use a mixed number, improper fraction. If you can use a decimal, like if it was 1/3, you couldn't use a decimal. If it's something that is an exact decimal, you can use it, but there is no rounding. So mixed number, improper fraction is best. Bless you. So the focus was 1, and then at 3, we went up a 6, so 3 and 1/6. Or you could say 3 plus 1/6, which is 18/6 plus 1/6. You could say 1, 19/6. I do not care, mixed number or improper fraction. Either one's the same. When you're adding, it's usually easier to do an mixed number. When you're subtracting, for some of you, just depends on how good you are with adding and subtracting in your head. For the directrix, we're going to go 1/6 below the line. So we were at 3 and we went down a 1/6. So some of you can see that's 2 and 5/6 very easy. If not, we were at 3 and we subtracted 1/6, which is 18/6 minus 1/6, 17/6. Or again, 2 and 5/6, whichever one, they're the exact same number, so it doesn't matter. But the directrix is a line. So we have to say y equals 17/6, or y equals 2 and 5/6, either one. Well, they're the exact same number. It doesn't matter to me, whichever one makes more sense to you, whichever one's easier for you to get to, the mixed number or the improper fraction. But you have to say y equals, or if it's a vertical line, x equals. The other thing, the axis of symmetry is going to cut the parabola in half. Since we know it goes side to side, the axis of symmetry is going to go straight through the vertex. So it's going to be x equals the x of the vertex, which is 1. Again, if it's helpful to draw that, you can. You don't have to. I don't like to draw it, but if you want to draw the axis of symmetry, you may do that. All right, and then the LR, the lattice rectum or the focal diameter, okay, is 4p. And it's the absolute value because it's a length. So that's going to be 4/6, which is equal to 2/3. So the whole length is 2/3. So from the parabola to parabola is not 2/3, 2/3. Okay, it is a total length of 2/3. So from the focus, we go 1/3 to the right and the left. So it's going to be pretty tiny right there. And now we can draw the parabola. Now, if you want other points, that's fine. But I have to see the vertex, the focus, the directrix, the endpoints of the lattice rectum, and then the actual parabola. So the domain, now we're just going back to what we've done forever. Domain is left and right, so negative infinity to infinity. The range, the low value is 3. And it goes up to infinity. Questions? This next one, we are going to have to complete the square on it because it is not in any kind of form that's ready yet. But we need to see, is it going to be x equals y squared or y equals x squared? The only thing that's squared is y squared, so it's going to be one of the horizontal ones. So our equation is going to be x minus h equals a times y minus k squared. So it's going to be the one we're not as familiar with. So we have to rearrange everything first to get it in the right order. So the 3x is going to stay. That number is going to come over. The y squared plus 8y is where we're going to complete the square. So wherever you have a squared, you can move it to either side. I want to move that one to the right because I want my y squared to be positive. All right, so complete the square. We take half of b, square it, and add it to both sides. So half of 8, since the leading coefficient's 1, we don't have to factor anything out. So 4 squared is 16, so we add 16 to the right. Add 16 to the left. With parabolas, you would only ever have to complete the square for either x or y. Circles, ellipses, and hyperbolas, you might have to do the x and the y. Parabolas will only be the x or the y. All right, now we just combine like terms. So we have 3x minus 15. Write this as a binomial squared because that's the whole point of completing the square. And the only other thing we have left to do is get that leading coefficient to be 1. So we need to divide every term by 3. And now we can write standard form. X minus 5 equals, we bring that, there's a 1 up here, so we bring that 1/3 out, y plus 4 squared. So now it is in standard form. There are lots of different ways to write these. This is the way we expect you to write a parabola in standard form. All right, and then the vertex is hk, so the vertex is going to be 5, -4. We get the h from the x and the y from the k, and the k from the y. And because we know it's going to go horizontal and the a value is positive, we know it's going to open to the right. Our focus is going to be inside and our directrix is going to be outside. Again, if it's helpful to draw that little sketch, I just think it's helpful because then when I plot everything, I know what I'm doing. But it's completely up to you. It's not necessary. So 1, 2, 3, 4, 5. 1, 2, 3, 4. There's your vertex. And now we have to figure out how far away to go to the directrix and the focus. So we need to find P. A equals 1/4P. A is 1/3. So 1/3 equals 1/4P. 4P equals 3. P equals 3/4. P is the distance from the vertex to the focus, vertex to the directrix. So focus is right here. So our focus is going to be, we were at 5 and we went another 3/4, so the focus is going to be 5 3/4. And the y value did not change. And then the directrix, we're going to go 3/4 the other way. And we can either make that a mixed number and proper fraction. So we were at 5 and we went 3/4 away. So that got us to 4 1/4. So the directrix is now x equals 4 1/4 or x equals 17/4, either one, whichever one's easier for you. If you don't know where I got 17/4, that was we were at 5 and we subtracted 3/4. So 20/4 minus 3/4 gives me 17/4. If you like that improper fraction better, both of them mean the exact same thing. This one, 0.25, 0.75, 5.75 is fine. You can write it as an exact number. 5.75 is exactly 5 3/4. If it's something like 1/3, you can't say 0.3. 0.3 is 3/10, which is not the same as 1/3. So that's why I would suggest leaving it as a mixed number or an improper fraction always, and you don't have to worry about that rounding issue. The axis of symmetry is going to cut this parabola in half, which now it's going to be a top and bottom. So it's going to be y equals the y of the vertex. The axis of symmetry is either going to be x equals the x of the vertex or y equals the y of the vertex, depending if it's horizontal or vertical. And then the only other thing we have to find is the length of the lattice rectum. So 4 times 3/4 is equal to 3. So that, remember, the lattice rectum, the focal diameter, that's the diameter that goes through the focus. So at the focus, we're going to go up 1.5 and down 1.5, and then we can draw our parabola. So we have the vertex, the focus, the directrix, the endpoints of the lattice rectum, and the actual parabola. Those are the things that we need. And now the domain. This is the lowest x value. So our lowest x value is 5, and then it goes to the right forever. Range goes up and down forever. So -infinity to infinity. So not quite as much stuff to find for a parabola, but stuff that's maybe not quite as common. The directrix and the focus, and then finding that p-value. So knowing a equals 1 over 4p, and the length of the latus rectum or the focal diameter is 4p. Those are going to be things that are very important for parabolas. All right, these last two problems. So find standard form equation of the parabola. Remember, on your quiz, everything's going to be mixed up. It's not going to be circle section, hyperbola section, ellipse section. This one, if I left that word parabola out, if I got rid of that word parabola and I said it has a vertex and a focus, that's not enough information to know whether it is a parabola, a hyperbola, or an ellipse. Now, if it says a parabola, we know what it is. But on Thursday, it's not going to tell you what it is. So if I took the word parabola out, that's not enough information for you to figure that out. I'd have to give you more information. So this one, the more information, is the parabola. Just like with hyperbola, we don't know whether it's vertical or horizontal, so we can't say x equals y squared or y equals x squared yet, so we have to plot some information. So the vertex it gave us was 0, 1, and the focus it gave us was 0, -5. So if this is the vertex and this is the focus, and we know it's a parabola, we know it's going to point down. So we also can figure out, we know what our HK is, because the vertex is HK, which in this case is 0, 1. So we know it's going to be a typical parabola, y equals x squared. So y minus k equals, we've got to figure out what a is, x minus h, which is 0, so it's just x squared. And then we also know that a is going to be negative because it's pointing down. So once we find our a value, we just want to make it negative. All right, so what we're going to have to use is the formula a equals 1 over 4p. In the two previous problems, you were given a and you could find p. Now you're given p so that you can find a. P is the distance from the vertex to the focus. So from vertex to the focus, that's a distance of p from 1 down to -5 or -5 up to 1, however you want to say that, is 6. So a equals 1 over 4 times 6, which is 1 over 24. And again, because it faces down, that's negative 1 over 24. And there's your answer. So given the information vertex and focus, this one had to give you a little bit more because of parabola. If a directrix is listed, we know it's a parabola. If an axis of symmetry is listed, we know it's a parabola. Just the vertex, just the focus, we're not sure. We have to get more information. All right, this one, focus and a directrix. So we wouldn't have to say parabola. We could leave that word parabola out and say equation of the conic with focus and directrix, and right there we know it's a parabola because only parabolas have a directrix. So the focus right here at 3, 0, the directrix over here at -3, because the distance from the vertex to the focus is the same as the vertex to the directrix, we know that the vertex is right there. So the vertex we know is 0, 0. And we know it's going to open side to side because of where the vertex, the focus, and the directrix are. So we know it's going to be an x equals y squared. So x minus h, h is 0, so x equals, got to figure out a, y squared. And we figure out a the same way. A is equal to 1 over 4p. A equals 1 over 4 times 3. So 1/12. It opens to the right, which is positive, so 1/12. And there's your answer.